And of course,
Fantastic.
as always, anyone stop us, ask questions all the time, chime in. Feel free to either hit us up in the chat or just unmute yourself.
Yes, yes. So today we're kicking off a new community coding arc. We're gonna try and do HTTP client generation from OpenAPI schemas.
I don't think we're gonna do generation though.
Okay, so I can't use the word generation. We're going to do HTTP client something
Yeah.
dot 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 from
We're gonna
OpenAPI
start with
schemas.
consuming the Open API JSON and see
Yes.
what we can do with it.
Yeah. So for folks who have folks like used OpenAPI before, I know.
Formerly known as Swagger.
Ah, yes, Swagger
Yeah.
is the old word. Okay. Yeah. You can pull down a JSON schema, look at it and describe your models, and then you get like a nice website for what your service API looks like, and it can help you, the clients, the colors of your API stay in sync, and it's sort of a polyglot solution for describing APIs. So, like many different languages support some kind of like creating a client from this spec. So, public APIs will use that as like a way of bridging multiple languages, and we want Unison to be a part of that. So, we're gonna try.
Unfortunately, Unison doesn't have any built-in code generation or quasi-coding or anything like that right now. So I'm not sure where we're going to go with that. But what we can do is just start to, ingest the API, and we could do things. We played around. Rebecca and I played around yesterday with the ideas of, seeing if we could at least validate that some JSON payload was going to be in the right form for what an API expects. Although we can't generate a client that will type check it necessarily at the time you're writing the code, we can at least check to see if the JSON is compliant at runtime. Like we could do something like not make a call to the we could create a client that says I will at least make sure your payload is compliant before we send it off.
Yeah. Yeah. So if you want like nice data types, you kind of have to make them yourselves. But if you can write an encoder into the JSON type, then that's probably more quote unquote type safe for you.
I think we will get code generation someday down the road. It's just hasn't made it to the top of the list yet.
We could do my super sketch idea of code generation, which is take the data
Right.
type and print it into a file.
Yeah. Well,
But that's a little hacky. I mean, a lot
we'll see
hacky.
where we get. Yeah, we'll see if we get there.
Cool. So I will show folks kind of what I've been thinking about for this. There's some cool testing utilities published by OpenAPI, so we've been kind of consuming their example server, which is like a pet store app. And they published like a JSON schema for like a pet store, and so we've been like plucking one of the data types there. And we've been focusing, Stu and I have been focusing specifically on the JSON schema portion because like the OpenAPI JSON spec is huge. There's like a lot of data types. The schema itself is where you describe the models of your API. Like this is a pet, it has a name. And I think that's the interesting problem. There's like some cool stuff you can do there. So with that, I will go over here. Are folks able to access the live share? I see.
I'm in.
Okay, cool, cool, cool,
Yeah.
cool.
And by the way, so those types up top, models.json value and models.json schema, are those coming from your library, Stu?
No,
The JSON?
no.
Okay, so these are
Um,
new stuff.
yeah, we were. So the JSON schema is obviously not something I had before. This is something new and this is not really. And what this type is doing is trying to describe. It's trying to capture um, most of, but nowhere near all. Well, not even most of. Probably half of what the OpenAPI says is valid for data types. So it's if this were straight up JSON, we might not have types like JByte, JBinary, JFloat, JLong. But since Swagger or OpenAPI, whatever you want to call it, does allow you to be pretty specific about, you can say things like this is an integer that can only be between 0 and 10, or you can say, you can say that this is a string, but it must be a valid ISO 9660 date or whatever it is. So here we're trying to capture something that's a little bit more specific than JSON. And so the JSON value up top is again is kind of the value land. That's where we would construct so the schema describes types in JSON, and the value describes values in JSON. So again, there we have things like jinteger, jlong, jfloat, which are more specific than just the number that you would have. In JSON, all numbers are floating point. And the reason we didn't here use my JSON library, which is generic and very specific to just JSON, is that if we use this more specific format, we can type check it a little bit. We could kind of do a more specific type checking to make sure we that if something is looking for an integer between 0 and 10, we're not just sending any number.
Yeah.
Cool. So the big complexity points of this, it looks like JReference, which is like another ref to some other piece of JSON schema, and JSUM, is that like an actual union type?
I actually haven't been able to find where I saw JSUM in the JSON spec. I think it is some sort of union type, but there's a to-do here where I have to read through the spec doc again. So
yeah, there's some stuff that we're probably just not going to capture. There's things in OpenAPI where you can do things like say, here's a place where you could put a value, and it could be of any type at all. Or there's places where you could say this can be one of these four, here's an array, and each element of the array can be one of these three different types. And so I think that's the type of thing where you might use a sum for, is when you have I have an array and it has to be it can be any one of these. It could be an int or a string, but it can't be a float. Those kind of things that we could use for some. I don't think we're going to get to, definitely not today, where we're implementing all of the spec, because it's got some crazy stuff in there.
Mm-hmm. Yeah. I put on line 38 an example of a schema object from from their sample. So this is the pet type. It is of type object. It's got two required fields, name and ID, and the properties there. So the sort of field names for ID, its type is an integer, int64. The name is of type string. So you can see the schema definition. The schema just defines sort of a data type. And in other languages, you would then make a class for pet, but for us, we'll do something like create a JSON value validator. Hello, Simon. Welcome to the stream.
Hey.
Hey. So we're talking through kind of what OpenAPI is as sort of a thing, an entity in computing, and talking about what we've done so far, which is create some basic data types to model the JSON schema described in the OpenAPI spec. So, yes. Okay. So, this is our schema object. We want to be able to describe it with our JSON schema data type. And if you pass in a JSON value instance, we want to be able to type check it and say, does this JSON value fulfill the requirements of the JSON schema that we've been handed from the API spec? So to that end, we started to write a type check function, which, if memory serves, is probably down here. Yes, it is. So this is sort of the validator. It takes in the schema and the value, and it walks both of them and tries to say, is this valid given the schema? And so far, it kind of works if you only have integers or strings in your JSON data type, or objects, which is sort of a recursive type, which is important to cover. But I figure we can fill this out more, continue with the validation story, and once we've got a proof of concept working validator, then we can kind of expand. So that's kind of the goal today, I think. Cool.
Sounds good.
Cool. So, yeah, what else do we need in order to say, interpret this schema? We've got the object type covered, the required list. We can do strings and integers. Let's actually run this for folks to see.
There's a place where we have a watch expression using it on line 128 if you want to not read it.
Oh, yes, I would like that. Oh, this let thing. Yeah, this is a bit hard to see. Okay, so here we've defined a schema that is what we would hypothetically get from this pet example. And then we created a JSON value that we're going to type check against that schema here in this watch expression. So this is the sort of thing where we're trying to get to pass. Okay, cool. I think we should add stuff to the schema and then sort of TDD it, then make the type check function pass. So I'm going to add something. Here, we'll do a field called is dog, so it's the name of the key, and then models.json schema dot. The reason it's property dot property is because of the constructor. It happens to be called property inside of this JSON schema data type. It's annoying. My apologies.
So additionally, if I'm understanding what's going on, Stu, in that type check function, what you're doing is going through all of the, I guess, like possible values for that type JSON schema. And you're looking at, I think OpenAPI spec defines a couple like validators that it could run, which are attached beside the actual schema definition, like the type definition. And you're just implementing those in terms of like check condition. Is that correct?
Yeah, so the type check function is going to take both a schema and a value and try to say, does this value match the schema? So like it's going to be like, all right, if the schema says I should have an integer on that first line and I have an integer, then I just make sure that the integer is within any bounds that might have been specified. And then I say, that's great. And a lot of these are just going to be like, okay, if it's a Boolean is what was specified and a Boolean what was given, then we're good. The more interesting one that we wrote yesterday on line 151 is we have an object on the left and we have an object on the right. So what we have to do is make sure that we have to go through the schema. The object will say things like there's a bunch of required fields. We'll make sure that all the required fields exist. Then we're going to go through all the values that we have and make sure all the values that we have are values that are allowed. And if they are, what I do is I take a value, I go find the schema that matches it, which might say this value is, and it could be a whole other complex object. So we say, here's what the schema says should be the type of this value and in this record, and here is the actual value. And then on line 159, you see we recurse down and say, all right, now type check the value inside that field. So all of these will be pretty much make sure the left and the right are the same. But the arrays and the objects are ones that will have to recurse for each individual value inside. That make sense?
Yeah, I think that does make sense.
Okay.
Cool. Excellent. Okay. So Okay. Stu, are you filling out?
I added Boolean and long just now,
Gotcha. Okay.
so you should be able to good to test the is dog thing.
Okay. It does not know what max is. Okay.
So one other follow-up for that recursive type checking. For JSON schema at line 155, is the object on the left, is that the JSON schema object attached to the JSON object that is provided?
So on the left is, so when you're defining a schema, when you say I have an object, what you do is you give it a list of all of the fields that could be on the object and say which are required and which aren't. Those we've called property. Can you, Rebecca, can you just like display property? Yeah, view, display, either one. So the property is, where is it? Unique type property. Yeah, can you view JSON schema.property? There you go. No. Right. Okay. So a property is basically, so the properties are a list. It's like a list of the name of the field that might appear, and then this property says what is the type, the JSON schema that refers back to what is the type of that field, and the Boolean is whether or not it's required. So in our examples there on line 38, you see we have one single object which could have any one of three different properties: an ID, a name, or a tag, right? And so in there we have like the ID as an int, and the tag as a string. We could have something in there where it's like the owner is a person, which has then a very a complex schema that we also have to check.
Which we might do next.
All right.
Okay, so if I mark the is dog property as true, then this value given should fail,
Right.
and it does not.
It
Is
doesn't.
is it because of this?
Well, no, it's as long as we have a Boolean on each side, that's fine. It's because it's required is what.
Oh, we don't have a required.
So 133 is where I'd start looking for the problem.
Okay, okay. Check that every required thing on the left is.
Oh wait. No, this is supposed to be false.
Okay, so our initial value needs to be false. Got it.
Wait, what is this? Oh yeah. No. Yeah, wait. Yes. And this needs to be false.
Okay, there's false. And then I'm going to make this, it's not required anymore, so now it should pass. And it does not. Okay.
All right, it'll be better now. No?
I have a.
Right before. Oh, now.
I wonder if this might be too overkill for now, but do you think it makes sense rather than returning a Boolean to return like an either and accrete like the list of paths on the left?
Oh, like for the type check function itself.
Yeah,
Yeah.
it might help us like diagnose where those falses are.
Yeah,
being
kind of do like
falsified.
a validated data type, like a error
Yeah.
collecting. Yeah, I think that's probably a good idea. That we will probably.
Does validated exist in base?
So interesting. No, but because types are structural in Unison, you could create structural type validated that happens to just look like either structurally, but then define different behaviors for like what happens if there's a left. I don't necessarily think that's a great user experience because of some conventions and what happens when you have two structural types. It'll just always pick either because of alphabetization. I did create a validated like wrapper type, which is in a different project that we could use, but we don't have one in base right now. But that's a good question. Yes, we should have a validated. We should have some sort of validator for this. Okay. Oh, you're making the either happen right now. Okay, perfect. Excellent.
If okay, if min is less than
And I guess maybe for people who might be watching in who don't usually use eithers, an either is similar to a sum type. It's just more explicit, right?
And either is, yeah, it's like either one thing or the other.
I think
Yeah, some type.
we're fast.
And I guess more specific, I just mean that you have to specify the constructor and it's not inferred based off of the type.
Yeah, I think I see what you're saying. Yeah. What Stu, is the either left thing being text?
It'd be some error.
Okay.
We can make these better, but
So we'll do. Ooh.
And just to narrate what I think you're doing, Stu. So you changed the type signature of that function, and then it broke a bunch of things at compile time, and you're just going in and replacing all of the instances of false with an actual more descriptive message of what's happening.
exactly.
Okay. Okay, I think I am missing a closing bracket here. I think we need to change this and because this is not a boolean. So I think what's our combinators on either for? I'm gonna find my validated instance. It's in one of my many code bases. So I'm gonna hop over to Unison share and find it.
I could see where the problem is. Problem is we never do anything with this check.
Yeah.
Does map have an any?
Does map have an any? Oh, like contain, like, does it exist?
Yeah.
Okay. Yeah, what Stu was asking is not like about the any data type, which I always immediately like, do we really need any? But there's a function called any on like list in Unison that's like, does this thing
Oh, it's called contains.
exist? So that's why I was confused.
Okay, so this fold left, that's our bug right here. And this fold left is trying to make sure that everything that we expect to exist does exist. And this fold left, this check is, did it exist? Did we already have an error? If we already had an error, then we should be failing fast, which we aren't really doing. I was using, so what do we do here? We really want to say, we're gonna switch this to right just so I can be cheeky and do it this way.
And one other call out about that map.contains function that Stu is asking about. Unison's a little special in the sense that you can actually query your environment to ask if it knows about any function definitions which match that type signature. So I think you can do find : I forget the way to specify free types, but like map kv and function from either k and v to Boolean. To Boolean, like you can specify that. I forget which one.
Oh, yeah, like look.
Yeah, like maybe one will be find like key exists, and one will be key and value exists.
Map, given a map and a key, does it exist?
I guess you would need to, in that expression, k is another unique type, so you'd probably need to do
Oh,
map of kv. Yeah.
so given a map of A and B and a return me a Boolean. I feel like that should be a thing.
Maybe you have to specify map of A, B, and a function from A to Boolean to Boolean.
And a function of k to Boolean. Return a Boolean. Our find by type sometimes is not quite all there. So I also wonder if I need to put the abilities braces in there. So I know we have a map dot does this thing exist function. So it's
Sorry, I'm gonna step away for like 5 minutes.
yeah.
I'll be
Okay,
back.
got it. I
Yeah,
will continue
unfortunately,
to look at
the
this.
type search indexes don't actually work as expected at the moment. We know about it, but
Okay, cool.
yeah.
Chris is on it. All you gotta do is be like, what's going on here? And Chris will magically have some sort of weird fix. And also it'll be represented in the LSP, so, not that I'm committing to that on video or anything. Okay. Back at the ranch here. What was Stu doing? I know I wasn't paying attention, and then he left. I was going to pull down validated because I like that more than what this is. We'll see if Stu nixes this, but we are going to pull this down. And then we can decide collectively if we hate it. Ooh, not that though. Okay. All right, so we have a validated type. It is a wrapper around an either of list of non-empty errors or A's. And there are some helper functions on that that's like collect errors, which might be nice in this circumstance. So I'm going to think about integrating this because I think these are wrong, but what?
So kind of thinking about that, what you're saying about the fact that Unison's got structural types and either invalidated get mapped to the same structural type. Do they have like a set of different functions for when you want to use like right biased map and right biased flat map versus like evaluate everything like applicative style?
Let me make sure I understand your question. So you're saying if either and validated end up being the same structural type, are there separate functions for like the left error behavior?
Yeah. So for I guess for like yes, like to in order to well, I guess let me think about it. So flat map doesn't exist for validated. So I guess as long as you don't use it explicitly, like to use flat map in some either composition means that you want the right biased behavior. And I guess as long as you don't use it, it's safe to assume that you don't really care. And it's okay to accrue things on the left. I don't really know. I haven't fully thought that one out yet.
So I think that's a really interesting question. And it's something I'm also getting my head around. I don't think either has a regular flat map in Unison. Like in other languages I've been in, it's just either dot flat map, and the convention is it's like to be right biased.
We have both flat map right and flat map left.
Yeah. So I think we have both, and then
Yeah.
I think how you'd it in the world where either invalidated end up being the same, the structure of the same type, you would just call your left accumulation error function something different, and that's how you decide if you wanted like error accumulation or fail fast semantics. The reason.
Well, the type signature for those functions would need to be different, right? Because you can't accumulate using flat mapping, which is why validation is not a monad because it doesn't have flat map. So the type signature would have to be like a list of validators or whatever. So hopefully that would clear up the confusion. But I guess you could also like, I don't know, have the get first left from a list of ethers, but I don't know. I don't think you'd rate that. I don't know. Doesn't seem like useful.
You could write it.
You could write it. But I mean, in that way, it's actually like kind of most nicer, I think, than Haskell because you don't have to like convert between either and validator. It's like, oh, in this case, I want either semantics. So I'll call the either function, like the functions from either, like flat map. And then, oh, okay, now I want to collect this in a validator style. I'm just going to call the like get all errors function. Seems nice.
Yeah, the reason that I've been rethinking this is actually some discussion from the folks at Kotlin who recently removed a validated instance from their one of their libraries. And I was like, oh, that's an interesting idea. And thinking through that, I was like, oh, maybe we should, Unison has some interesting typing where like that concern is less obvious because of structural types. So yeah, it's cool to think about. Right. So, oh, I was trying to make this thing type check. Oh, and Stu's back. Thank you. We weren't sure what you were doing, Stu, and therefore went on a nice discursive conversation about validated. Da, da, da. Find map fold right. Oop, sorry. Find map dot fold right with key. No worries. Okay, fold right with key takes a key and an A, return and a B, returns a B.
Right. Needs a key. That's the name, a key, and then a right. I might have messed this all up.
So,
All right. What are we doing here? Let's turn this back to a fold left and try this again. And this is the check.
should we extract this function that's an argument to fold left with key into a function itself so we can see the types better?
Yeah.
Okay.
Probably should.
Okay. I'm gonna start doing that. So, go. It's gonna take an. Oh, thank you, Copilot. Is that right though? I don't think it is. It's not. So this is gonna be. You give me a text and a value with is a JSON schema. And then an either text unit, and I give you an either text unit, and that's the foldy bits. So key value accumulator equals. Ooh.
I'm lost here.
Oh. Find fold left. We changed it back to fold left with key.
Yeah.
Okay. I will. So that is. What is check?
So the fold left, like we're going through and we're trying to see if each one did we checked it and did we get a right or a left? And if we got a right, we're going to keep going. If we got a left, we're just going to return the left. This is and this is not exhaustive either. Like we want a way with, like basically to fail fast, but I don't really have one. So I'm saying, do we check? Are we good? If, right. This really should be. So it's like, if we were good, then we keep checking if we're good. If not, we fail on the left. Is that right?
Where does this thing? Here, I will comment this out so we can see if this is type checking.
Wait, we can't comment that out.
The go thing that I was
we're
writing.
inside there. Oh, you were just writing that?
Yeah, I was writing that. I was gonna move your functionality into Go.
Okay, I see. Like this.
Yeah. But okay. It does not like the equals. I wonder if this thing here, this right, is throwing it off. I'm gonna delete that. Still.
What is wrong with this equal sign?
Check required. Does it not understand that it's a function? Okay. Check that with... No. I wish it would tell us the... Okay, let's try something else. No, it's still failing this thing. Is it this thing on line 156 that maybe got copied wrong?
I don't know. Oh my god. Look at this.
Is that... Oh gosh, all right. Oh, and I think this needs to be exactly the same level as that, yeah. And this...
I got this. All right.
Oh, should this be either now? This should be like a left of...
It is.
So where we're at now, kind of back to the same spot where we were trying to run the validator, but now we should have descriptive error messages about where it failed. Is that correct?
We're getting there, yeah. If we can make it type check. then in theory, at least, you'll have to like right now you'll have to run the validator thing multiple times, but it will tell you what's gonna miss. So one step at a time. It's getting better. It's getting smarter. Our type check function. I think we might have a Boolean in here hanging out somewhere. Right, left, left, left.
Oh, oh. This needs to go back in. Wait a minute. Wait, where is the list of value I want equals name? Where's name? Right, we need a list. What list are we checking this in? Yeah, okay, I understand.
Do you just want to move it down back into the
Yeah, it needs to
object?
be in there. We're closing over something in there.
For scope? Yeah. Okay, I was going to fix these because these return either's and there's no and operation on either. So I think we need I think we need flat map right.
Well,
Or is there a or else
yeah.
on either? I'm forgetting basic functions.
There is.
Either dot or nope.
In Haskell, it'd be like from left. Is there like a from left or from right?
Let's see. No.
Can't always use. Oh, if they have the either combinator, which I don't see that in here either. Weird. Oh, you can use fold. You just have to provide like const as one of the sides. But
I'm deciding if I want this combinator bad enough to write it now. I'm debating. Is this useful for people? Do people ever want to compose either's left or right? I mean, maybe. Clearly, that's what I'm trying to do right now. So maybe I'm answering my own question.
You are people.
I am people. I am
And
Unison programmer, and I want this.
Therefore, all Unison programmers want this.
But I don't know what to compose.
Why does that not exist already?
I feel like this exists, and I feel like this is me not finding it, or maybe my base version is old. So I'm just gonna double
Let's take a look.
Either. Oh, it's under data now.
Right. No, it's definitely not here. So.
There's map left, map right, flat map left, flat map. All right. Well.
How do we not have this?
Combine right?
No,
I guess
it's well.
Because you have to pick a direction now.
Oh, that's why we don't have it, I guess, right?
What do you mean?
Sure. What's the type of the thing you're trying to write?
Oh,
Oh.
Or, okay, if we could, I mean, I guess you could be like, take, I guess it would be that, like, I give you an either of A, B. If it fails, left, my first argument, return left, so it'd be the either of A, B. if it succeeds. I'm trying to think if I need to have like a B arrow B, like a combine the right sides for this, or if
So this is like take first right.
yeah, the semantics I'm thinking about is like the in option, you can, like option 1 or else the second one.
And then in the case of failure, I guess, well, the one that he's writing would have to take the left one.
Yeah.
The lift A to const, except more general in the sense that the left can be a different type of the second argument, but that's not helpful for anyone.
Yeah. Maybe this is well,
Why, like, in what case do you not need the, like, yeah, I don't know. Or is this just alternative? Is this alternative?
oh, is that a function?
No, it doesn't exist, but like it's type class or whatever. It's the monoid on applicative functors. So it
I've usually
basically,
heard people use like the dot or else. Like I think that is defined in alternative a lot of the time.
yeah, like or else is kind of like a name for the monoid on applicative functors or whatever. But in this case, it would just be like, hey, take like the first non-empty thing. Although in order to pass the laws, there's a bunch of stuff, but we don't care about laws because we don't have type classes. So either dot. I like how it's
Oh,
either or.
either dot or? I love that.
Interesting.
Also a very good book.
Was that a Kierkegaard
It is. Oh my
reference?
God, Simon. It was.
Well, I know my one Danish philosopher.
Oh, that's right, because he's Danish. That yes, props. Some national pride. Okay. Gotta fix this. What is this values hanging out here for? Oh, are we missing a parens? Is that's
Yeah, this is not supposed to be there.
okay? Is this? I'm gonna. Make that indented. And then this needs to be, oh, no, there.
It has to match the right.
It has to
no
match the right. Okay, I think it's matching the right, but it's failing for some other reason.
Somewhere we're returning a unit.
So the return type of this last thing is still Boolean, so that's probably, this needs to be,
Oh, this is a unit right here. No, this.
required check has failed. And then this needs to be right of unit. Is that right?
Where are we? What is this? What are we doing? We're folding over the values.
Yeah,
right?
so the initial value for the fold left is success. I gotta think about that.
We're still not doing anything with this check value.
Yeah, I feel like we're not doing the foldy bits. Where's the unit coming from, though? Does this need to be extracted
Yeah.
as a variable? So this should be
Yeah, let's do it.
requireds. Figure out the name later. So for this one, is this requireds thing like the first step in a check, or?
Yes. Wait. Yeah, where are we actually doing the check? We should be required, check required. Where are we actually? This should be out here.
I think I have lost the plot in staring at this requireds thing.
Yeah, all right. Okay. So, well, what is this type optional? Oh. All right, so we have two functions here, check expected and check required. Check required is going to make sure that everything that is marked as required exists in the values, and check expected is check each value and make sure that it's something that was expected in the schema. So expected is something we're folding left over with key. I just don't understand what this current error is.
The offset
Found a
error
value for functional.
or the maybe tuple.
Maybe tuple.
Oh, so we're matching on an either here, either text, but we're decomposing it as
right. We need to.
option.
Oh, right. So we need to know if this is a right. That's what I was in the middle of doing. All right. So if we already found something on the left, so if this is a rate and where does the sum come from? Right. So what are we doing? We're matching on our previous results if it was good, and then we have then we found something in the map. That's great.
Oh, that's the okay.
If it's if it's we were good so far, and then this is no good, then require, and the other case is otherwise anything on the left gets returned.
Okay. We don't need that then, because that's just returning an either.
No, that's here. What is the issue?
I
Yeah,
found a
that's
value
cool.
of
It's
type
not helping
tuple.
anywhere. Okay, so right. This is match that with. Okay, so we check all the required. If that was good, then we check all that. If it's left, then we return the left.
Oh my God, Stu. Oh, look at that error.
Okay.
That's beautiful.
Half hour later. Yep. Okay.
Okay, I'm
And
gonna
then
say
let's
it's not
say
required.
missing required fields, and we should be able to
X,
say.
it's yes. Okay. Okay. Cool. Everything is great. Okay. So our required and our validation should work now. If I make this, let's see, min has a maximum value. I'm not sure if I expected that to pass, but if I say J schema I think we have a little issue. In that it is succeeding when it ought not to. So I've set in my schema, minimum value is +1, maximum value is +10. And then for my ID, I give my JSON value +1,000, integer 1,000, which is more. So let's double check if these arrows are right. If the minimum is less than...
Oh, it should be the other way, right?
Yeah, this needs to be the other way around. Oops, it's an arrow. Yeah, and
No, I don't think that's. I think.
So this is the min given by the schema. So if the
Right.
minimum given schema
Is greater than ours, then that's a problem.
Oh. Right.
Oh, I know why. Our or is wrong. We don't want or in this case because we don't want the first success. We want the first failure.
We don't want either or.
We want either nor, which is not. I don't even know what that is.
Either nor. Yeah, I've never heard of that functional combinator before.
No,
Well, I think we
the
need
right
it
word
though.
for it.
Yes. Yeah, what is that?
That's I don't know. This
It's
is a
either
weird one.
nor. We're pioneers. Okay, well this one isn't a Kierkegaard book, so my apologies. Oh, this needs. We can make the types here. The types have to be the same, but these can be different.
No, no. We want them all the same. I think.
You want them all the same?
I think so.
Because okay, let me think about this. I want to take
We
the
can
first
let-
failure,
Yeah.
I'm preferring. Okay, we'll keep it simple. We'll just make them all the same. Hey, look at that.
So is the difference in behavior? It's similar to or, but we want to like continue running and accrete the values on the left.
We have
Basically, it's not. It's right. One's a right or and one's a left or. We really needed the left or instead of the right or.
but we haven't done the accreting of the errors yet. So
No, I don't know that we're going to. I guess we could.
we can do that if we wanted. I think we should eventually, but I'm trying to think if parsing the JSON schema is truly an applicative style like thing, or if there are dependent computations within it that ought to be fail fast. I gotta think about that. I think we could model it as validated, but we can do that in the future too. Let's see. Where's this failure? Da, 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 da. Oh, are you doing the array one?
I am doing array real quick.
Yeah, that's a good one to do because it's another one of those recursive ones. A lot of the others we can just do offline because they're not terribly interesting. But
This is what? Oh boy. Okay, this is an interesting one.
okay.
All right, so let's do it this way. Okay, so okay, what do we do? Okay, so for the array, what we have is we have a list of possible acceptable types. So what are we doing? We're going to take a value for every given value. We're going to fold over it, and we're going to say. So we're going to fold. Okay. Valid value. We're going to fold right with some function, assuming that it's all fine for every value. And for each one, we're going to do a value. If everything's been going okay, then what do? We say, is there anything in the fields list such then we're going to assume that and what do we do here? We're going to say, given this schema, we're going to try to type check it.
So is that so for the is that correct? Like we want to model like so if I'm understanding that correctly, the array of things that we pass into the JSON schema.jArray is modeled as a sum type validation where we say either this combination, like any of these JSON schemas apply. And we also don't, that feels like kind of confusing.
It feels like what?
I don't know. But like it feels kind of like confusing. I don't know if that's.
Yeah, I agree, but I'm not the one who invented Swagger, so you can take that.
Okay, gotcha.
Okay, so it's confusing because the spec and its relationship to the JSON is confusing.
Yeah, I mean this is just that's the way OpenAPI works. You can give it a list of possible types that go on over the arrays.
You can give it a list of possible type. So it's not an array of one thing.
Oh, it's.
Do you think that makes sense?
This is not has to do with how many items are in the array. This is just what are all the valid things that could be in this array.
Do you think it makes sense to further specify that as JSON schema.jArray of JSON, so it's clear that that's what we're doing?
Well, I don't know.
I still haven't figured out what the JSON thing is, and
I don't think we need it. I don't think we want it. I think
Yeah.
it's trying to do this. I think it's because.
I think that's right. Yeah.
All right. So what's this current error?
Oh, sorry. Da, 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 da. It is saying first argument to list any has type either, and it should be a Boolean.
Right. Okay. So we got to do it fold again.
Or could we just do either dot is left, or is that?
We got to do it. We got to. All right. What are we doing here? We're trying to fold over each possible schema. And what are we saying? We're saying, given a new schema,
Oh yeah.
we have to see if I found, now here it is, if I have found, if it's a left, then we keep going. We try to type check the next schema. And if it's a right, then we return it. We're done.
So fields fields is a list of either's?
No. Fields is a list of all the possible valid schemas. So we're going to look through each one. And if the previous one was a left, meaning that wasn't the right one, we have to keep going. If the previous one was a right, we're done. We return it.
Okay, and if at the end there's no valid schemas.
We start off saying, well, I haven't found a valid schema yet.
Okay.
All right, so what's this current problem? Second argument to list.fold right. Oh, that's just
Oh. Third argument to list.foldRight has type example.
what?
Arrow maybe text. Interesting.
Oh. Wait,
Should this be values? Plural?
wait a minute. Where are we doing this?
I think it should be values.
Yes, I think you're right.
Hey, it type checks. Okay. We should write a JSON schema, JArray in this thing. So I'm going to do that up here for our testing. Okay. What kind of array could friends? Sure. Dot JSON schema dot property dot property JSON schema dot J array and it is required.
Maybe we can start by making it a JArray of singleton list of JString.
Yeah, that's a good idea. JSON schema dot JString string none. I have to put this in parentheses. Is that not the constructor? JSON schema dot JString nat. Should be okay. Oh, comma. Needs to be a tuple.
This isn't one where we messed up the constructor names again, is it?
What's that? I don't think so.
I think you might still need to put the JArray schema in an array.
I think you're right, yes. JSON has type. I have an extra boolean. Sorry. Okay, the property constructor. I have an extra.
Oh, there's a comma. You don't want a comma here.
Oh, thank you.
There you go. Oops. Oops.
So this should fail.
Well, that did fail. Oh, what did we hit? We hit something that we had a
hit
pattern match
pattern
failure.
match.
Did I put something in that we didn't have a?
You used.
Oh, wait. This is a pattern match failure. That's because it's a schema. Yeah, we don't have a. Okay, wait. Watch this. Watch this. We need a default. We need an otherwise. What's wrong with this? I can't do an otherwise with a. That's a.
Yeah, well, I'm gonna move this down to the bottom.
Fine.
The last, it's gotta go down here. Oh, did we not have something that communicated like a failure of type checking? Is that?
Yeah, we just didn't have a. If you, I was expecting a string and you sent me an int. We didn't have that case. Do we want this so we can print a pretty print?
What do you? Oh yeah, we do want a nice toText function for our JSON schema and JSON object type stuff.
All right.
Do you want me to multi-select that?
Yeah, do that if you're
Okay.
better at that than I am.
Oops. I am going to do that, and then, oh, that's not gonna work quite as nicely because there's some of these. Okay. People are really getting to see how the sausage is made for these libraries. Should should the JObject toText thing itself be recursive?
Nope. We just, I don't know. Oh, we could, but I think we just, this is just so we can say, like, expected, got this, expected that, right?
Right. So if I'm in a deeply nested object, okay, did we write it so that we operate on the leaf nodes of our recursion first, or are we operating on the root nodes of our recursion first?
We're going to go depth first and find the first error deepest we can.
Okay, then I'm cool with object just being object because we'll hit the type check failures on the leaves first. I was worried about like, okay, a type check failure has happened. Object is not equal to object.
That is what we're gonna get right now.
Well, I think
Ooh.
also the when you're traversing through it, I think it's probably going to it's going to say object was not equal to, and the right side is a value expression. So you're going to see the value of it.
We'll see. Okay. 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 Yes.
What's this problem with J reference?
Find J. J reference has, for the JSON value, has a text argument. But for JSON schema, it does not. Oh, right. Do you want me to multi-paste all those?
You can do it.
Okay.
Oop.
Where's that left in? Right. Oop. Actually, we don't have this one. Got blank expected. Oh, you fixed it. All right. Line 55. Okay. Do folks have any questions about OpenAPI schemas and the JSON validation we're doing so far? I realize some folks have joined. Just pop them out if you have any questions or thoughts. We're just trying to write this type check function so we can type check JSON. So if you hand us a JSON object and it doesn't match the model specified by the OpenAPI spec, we'll hopefully fail and give you a message.
All right, what's going on now?
We just need the service to be implemented using Unison, so we can just send a Unison request.
Yes. That is what we want.
I mean, it kind of thinking about that makes me think of the insanity of what is required at the moment to connect to things.
Yeah, I mean, ideally, for the cloud and for like services, we're thinking about, you know, how do we make cloud services themselves composable? You know, Unison data type, output and inputs, just link them together. And so you do, like, it's such a cool idea to be able to have truly composable microservices without all the boilerplate stuff. So, you know, in some ways, OpenAPI schemas and client and server generations are an existing way of solving a problem that in the future Unison may solve easier, one can hope. But of course, you know, at the edges of the system, you've got like the sort of hard candy shell and then the delightful Unison chocolate interior. You know, you gotta handle the outside world. So that's
What is-
that's what we're trying to do.
I have no idea what this error is. Oh, there it is.
For the value level, Stu, do you think it makes sense to just output whatever the value that we got is for the sake of like debugging?
Well, maybe. Well, then we got to do a recurse. We have to. I don't know. How you, it would be
Can you
better.
just debug
maybe.
.totext?
What'd you say? Oh,
Can you just use like debug.totext?
To get a text value from any type.
Yeah, specifically from the JSON value, just because like it might be less of a nice user experience to see like, hey, object didn't match date time, and figuring out where that happened is tough.
Yeah, I like that idea. I think we should have our users have a good experience and like print it out. I know probably for a fact we can't use debug.totext and have it work in the cloud because of some like we sandboxing. Like we don't want to let people spuriously run their cloud compute and be like debug.totext my secrets file. But for these primitive types, like, we could turn a double or a float into a text and print it out. And I think that will be a good experience for people. So what's this error? Oh, it doesn't know which to text. You want JSON schema to text? Hey, oh, that's a beautiful error message. Okay. I will go back and make this debug to text not just be debug to text, but this is a good proof of concept. So very cool. Let's see. Oh, are you changing our test stuff?
I'm just saying that we make a pass. Yep.
Okay. Yeah. Okay. I feel like this is a measure of success. We should plan out what we want to attempt next community coding day,
Yeah.
because we have.
Well, I want to test real quick that our logic works on this. So we know that we can't use an invalid value. Let's try more than one. Let's do the janky thing that we no one ever wants anyway, which is to say that friends can either be strings or ints. Does that make sense?
Yeah.
I don't think it makes sense, but we can go for
I
it.
don't love it as a supported feature. but if it is there, then we should attempt that.
Okay, so now
So this should still
we
succeed.
still right, but we can also add a JSON value dot j integer +2 +3. What did I spell wrong? Okay.
JSON. Okay.
So we can do that, but we can't do JSON value dot j
Boolean.
binary. true. What did I spell wrong this time?
Does the
Yeah.
argument to J binary have to be
Whoops.
bytes? Or
Yeah, that's probably a bug. What was a J long? Or, cool. Oh, expected string.
expected string? Oh, we should.
That's the hard one. That's not going to be an easy one to fix. It's going to be whatever one we tried last.
Okay, would that change if we changed from either's to validated?
No. Well, sure, but we have to figure out what you want to do with our nor function that we made up.
My favorite function, my new favorite function, either dot nor.
Yeah.
I guess that only occurs when you're doing the sum type checking, though. And you can have like specialized behavior to say like, hey, if at least one of them passed, don't collect any errors. If one or more failed, then fail and collect the errors, and then combine it with your global failure structure, which gets kind of complicated, but I actually don't know how to represent that.
Yeah.
Okay. Well, I feel like even the fact that we've provided some type failure information is like yeah.
I'm proud of what we've done today.
I am very proud. Look at us. I mean, we can't do full code gen yet, but maybe
No, we didn't get to full code gen.
one day.
We went from checking integers to checking integers and arrays.
Rome was not built in a day. Yeah. Okay. So next community coding session, yeah, we'll try. I'll try and like fill out.
We
the
should
rest
fill
of
out the rest
stuff.
of this in the
Yeah.
meantime.
Yeah.
I think we could get a lot of the rest of it done, and then maybe we can talk about actually parsing the Swagger spec.
Yeah. Next time we'll need your JSON parsing library, and we'll start parsing stuff into data types. But I think this is a great place to stop because yeah, we've got like the JSON schema hard stuff, started, and yeah, it'll be good to hopefully start generating clients someday. Cool. Anyone have any questions? We good? Thanks for joining, folks.
Yeah, thanks everybody. Thanks, Rebecca.
Yeah, we'll see y'all next week.
All right. Take care, guys.
Bye.